Hello viewers, welcome to UN College Digital Class. In this session, I am going to discuss about the three different phases of compilation. In the previous section, already I have discussed about the three phases. Those are lexical analyzer, syntax analyzer and semantic analyzer. In this session, I am going to discuss about the next three phases, and if you have not gone through the previous session, then please go through that video so that you can understand this one very clearly. Let's start.
At the end of the lexical analysis, syntax analysis and semantic analysis, the fourth phase starts its operation, that is intermediate code generation. Whatever program you have written, that is the source or the starting point, and at the end of compilation process the outcome is target code or machine understandable code. Okay, in between these two phases, means starting and ending, there is one, this phase is intermediate code generation. It means that it converts your code into an intermediate text or intermediate code. The main objective of this phase is to make easier the compilation process. Okay, for example, take one example. Suppose you will be asked to do a job, you will listen the instruction and you will do the job, no doubt, but in between the listening the instruction and doing the job, your brain is also mapping according to your comfortability zone, that is intermediate code generation. In this slide, I have mentioned that after the end of the semantic analysis phase, whatever the output has generated, that is taken by the intermediate code generation phase, and the intermediate code is generated. Now I have mentioned one example so that you can understand it very clearly. Okay, I have mentioned here total equal to count plus rate into 5. You can take any expression, any statement, no problem, just like x equal to a plus b plus d into c, whatever you want to write, you may write. There must be one expression. Now we will discuss how the expression is converted into the intermediate code. Actually, there are some techniques are used here, just like the number of variables, according to the number of operations we are taking the temporary variables. Okay, for this expression I have used t1, t2, t3, all are temporary variables which are used in intermediate code. Okay, for the first statement, t1 equal to int to float 5, it means that here we are converting the 5 into float type. Then t2, we are calculating t2 as t2 equal to rate into t1, but means that rate into 5.00, as it has already converted into float. Then the next is t3 equal to count plus t2. It means that we are just coming from the right to left. Okay, I think you are getting this one. When you are calculating one expression, it is either from left to right or right to left. It is calculated as from right to left because multiplication has the greater precedence in comparison to plus. Then in this way we are calculating here t1, t2, t3, all are temporary variable. Then the next phase is, which one is more interesting and more powerful mechanism of compilation, that is code optimization. Here, when the compiler converts your source code into machine understandable code, okay, it perform number of optimization techniques. Okay, the objective of the code optimization phase is to improve the performance of the program execution, and the main goal is that how the execution will be faster, how the program will take minimum memory, or we may say that the main objective is to maximize the resource utilization. And the resources are here, that the time of the processor and memory of the system. And I have already mentioned some points, means some advantages of code optimization. Those are, it improves the execution speed, it uses memory efficiently, it gives better performance, and all these, and overall we may say that it improves overall performance of the program execution. Now we will discuss how the optimization is taking place. Okay, there are two different types of code optimization. Those are machine independent and another one is machine dependent. Now we will give one example of code optimization. Let the coding is a equal to int to float 10. It means that there is a conversion of 10 int to float, then b equal to c into a, then d equal to e into b, f equal to d. It means that let we are assuming that these are the codes. You may write anything, no problem. Okay, now it may be optimized. Okay, it may be optimized as b equal to c into 10.0. Why it is 10.0? Because we have already converted into float. Okay, if when we are converting a int into float, int constant into float, so by default 0.0 will be added. So directly without converting, directly you can use 10.0. So it is code optimization. If you are using a function for converting, then it will take more resources. Instead of converting, instead of using a function, just add 0.0. And the next is f equal to e plus b. Okay, so that we can eliminate or we can minimize the code. In this way we are optimizing the code. Now we will discuss about machine independent optimization. Actually there are various type of system architecture. Okay, suppose you are performing some code optimization on a particular code and that can be implemented in any sort of architecture, then that is called as machine independent optimization. Okay, it means that here the compiler is not considering what is the architecture, what are the CPU register, what are the memory location, etc. But in case of machine dependent optimization, it is just the reverse of the machine independent. Okay, in this type of optimization, once the target code is generated and the code is transformed according to the target machine architecture, it means that in a particular system the optimization which is made in a particular system that cannot be implemented in other system architecture. Okay, now we will discuss some other aspect of machine dependent optimization. In this optimization technique, CPU registers are included, memory references are included, and one more thing is that machine dependent, in case of machine dependent optimization, more benefits are included in comparison to machine independent optimization. Now we will discuss about the last phase of code generation compilation, that is code generation. It is the final phase of compiler. It takes input from the code optimization phase. Actually the code optimization phase generates the output and which is passed to this phase as input. Okay, and this phase is responsible to convert that input to machine code or machine understandable code. And at the time of converting, it must take care that the original meaning of the program code must not be violated. Okay, and how much efficiently that can be used, and that must be based on, that should be based on according to the system architecture. Now we will discuss something more in depth. The target language is the machine code. It means that in this phase it refers everything, machine location, registers, everything, all are allotted here. Now I will explain code generation, which is the final phase, by giving one simple example. Let the statement is a equal to b plus 60.0. Okay, it may be converted as target code as following. How? Here in the following code I have used three different registers, R1, R2, R3. Okay, R1 is referring A, R2 is referring B, and R3 contains 60.0. Then next is that we are adding R2 and R3. It means that B plus 60.0, which is stored with R2, and at the end we are just transferring the values of R2, which is the intermediate result, to the final variable, that is R1 or that is A. In this way it may be generated or it will generate the target code. Now we will discuss one of the important concept which is associated with compilation phases, all the compilation phases, that is symbol table. When the compiler performs the different activities in the different phases, it needs some memory. Okay, it needs a particular specific data structure to contain all the information regarding the particular program, and symbol table is used for that. Symbol table is a data structure which is created and maintained by the compiler. It keeps tracks of everything. It keeps tracks of syntax, it keeps tracks of semantic, it keeps tracks of binding information about keywords, about variables, about memory location, classes, objects, everything. Yes, now it is another important concept which is associated with compilation phase, that is error handling routines. During compilation there may be some errors, may be there, obviously errors may occur. Okay, programmer may do some mistake, and for that reason there may be some errors, and we know that there are basically two types of error we will discuss here. One is your compilation error or grammatical error, and another one is logical error. But particularly here compiler is handling grammatical error, which is called as syntactical error or syntax error. Now we will discuss how the error handling routine is performing the task. Okay, in the compilation phase, in every phases error handling routine is working. Okay, we will discuss it one by one. In lexical analyzer, the error handling routine is responsible to check wrongly spelled tokens, because in lexical analyzer the lexical analysis phase is responsible to find out the tokens. So here it is the responsibility of the error handler to find out wrongly spelled tokens. Then we will discuss about the next phase, that is syntax analysis. In case of syntax analysis phase, the error handler is responsible to find out the missing parenthesis. Okay, and the next one is intermediate code generator. In case of intermediate and everything, actually error handler is responsible to find all sort of syntactical errors in syntax analysis and semantic analysis also. Now we will discuss about intermediate code generator. In case of intermediate code generator, error handler is responsible to find out data type mismatch, operands in case of particular operation. Then we will discuss about the code optimizer. In case of code optimization phase, it tries to find out all the statements which are not reachable. Okay, then in case of code generation phase, again the unreachable statements are tries to detected by the error handler, and at the same time it also performs some error handling task on symbol table also. If the compiler plays a number of multiple declared identifier, then it will also find out in case of symbol table. I think that you have got some basic idea of compilation phase. Actually this is the fourth session. In the next session we will discuss more in depth level. We will cover everything, how it is working, what are the different data structure, how the symbol table is implemented, everything. If you have any doubt, then please write to us so that we can provide you better service, we can clear your doubt. Thank you so much for watching. Have a great time.